Hello ladies and gentlemen, my name is Sabine Giegelmeier and I'm Business Development Manager at the Fraunhofer Institute for Building Physics. Today we will briefly look again at the human energy balance. Then we will get to know a system by which we can evaluate how a climate is likely to be estimated by a person. Finally, we will apply this method to our building and climate in LUCKNOW. Let's start. As we learned before, for the full functioning of all organs of the human body, the core body temperature must be maintained at around 37 degrees at all times, irrespective of climatic conditions. For the body, it's easiest to keep its core temperature when the body is in the thermally neutral zone. The graphic shows the thermal neutral zone, the core body temperature and the heat emission. All of it is depending on the ambient temperature that you can see down there. For each person, depending on the boundary conditions, a certain temperature range is perceived as comfortable. This is the thermally neutral comfortable zone. Here, no changes are desired in order to achieve thermal comfort. In this thermally neutral zone, the lowest heat emission of the body takes place. If it gets colder, the body temperature drops, and in the worst case, death by freezing occurs. If it becomes warmer, the body temperature rises, and in the worst case, death occurs by heat collapse. In the video about comfort enhancement in LHP, we already had a look at the human energy balance. You remember? Here is the equilibrium equation again. We will look at it again from a slightly different perspective and assign the individual components of the equation to the areas of the body, clothing, and environment. H corresponds to the internal heat production of the human being. Heat loss occurs by water vapor diffusion through the skin and by evaporation of sweat on the skin's surface. Furthermore, there is latent heat loss through respiration and heat loss through dry respiration. The result corresponds to the value K, which represents the heat transfer from the skin to the outer surface of the closed body, and can also be divided into R and C, where R is the heat loss by radiation from the outer surface of the closed body, and C is the heat loss by convection from the outer surface of the closed body. Whether the energy balance is balanced depends, among other things, on the outside temperature and the relative humidity. The bioclimatic diagram by Olgay illustrates this relationship. As the model shows, one is normally outside the comfortable area at 30 degrees outer temperature and 70% relative humidity. There are now two ways to reach the comfortable area. The first option, to enable a comfortable indoor climate, is to lower the indoor temperature to 25 degrees. Here you can see that we are now in the comfortable range. The second option would be to leave the temperature like it was and lower the air humidity instead to 48%. Then we are again in the comfortable range. What I want to make clear to you here is that the combination of air temperature and relative humidity play a very large role in personal comfort. The consideration of one of the two variables alone allows only limited information about whether a person will feel comfortable or not in a specific climate. Let us now move on to our lighthouse project in LUCKNOW and apply our presented method to the anticipated indoor climate in the constructed buildings there. The first thing we do is to get an overview of the climatic conditions. As you can see on the left side, The summers in Lucknow are quite hot and the winters are quite cold instead. The temperatures go partly over 40 degrees and fall in winter to under 10 degrees. The rainy season takes place from July to September. Through the year, relative humidity is quite high. As we have hot and humid summers and cold winters, we have to avoid overheating here as well as too low temperatures. You see, we have very challenging conditions. In the next step, we calculated what climatic conditions will occur in the buildings in Lucknow after their completion. You remember, it is a stay-in-place formwork system consisting of concrete in a PVC formwork. The construction is uninsulated and there is no active cooling or heating foreseen. For each day of the year, we have calculated an average value for the prevailing temperature and relative humidity in the room and plotted it in the diagram. 1 point corresponds to 1 day. Here you can see the results. The area in which the occupants feel comfortable is in the comfort zone. As you can see, a lot of points are outside this area. This means that the residents will probably not feel comfortable in their apartment on many days of the year. Some of it will be too hot for them and some of it will be too cold. Now what could we do to improve the conditions? What we haven't looked at yet is the information in the graph about air movement and about radiant heat. You can see that there is information about the air movement. That means that the comfortable range extends to the respective line when the respective air velocity is provided. Moving air transports heat away from the body surface, allowing higher temperatures or humidity. So if we provide for a relatively high air velocity in Lucknow in the room of about 1 meter per second, we can ensure comfort at least for most of the days. However, we should not do this by opening the windows. Otherwise, only more hot air will be brought into the room. Better suited, for example, would be a ceiling fan. It is similar with the area that is too cold. If we provide additional radiant heat in the room, for example through radiators, we can also extend the comfortable range downwards. In Module 3.3 on energy efficiency, we have already determined that the use of lightweight concrete makes sense from an energy point of view. Now we want to briefly examine how this more energy efficient construction method affects the comfort. Here you can see the result for the calculation with the construction method with light concrete and therefore higher insulation values. Energetically, this is a significantly better variant. Climatically, we also have a certain improvement compared to the heavy concrete, but the difference is not as big as expected. We have slightly lower values for the relative humidity. However, if we want to actively heat or cool the room, this lighter construction method makes much more sense from an energy point of view. With this, I say goodbye for this video. Thank you for your attention and see you next time when we will have a look at the comfort in the lighthouse project in indoor.